like to introduce James Henderson, who's an automation solutions architect at Ductus. He has over a decade of experience in the telecom industry, specializes in network automation, and my notes say he's expert in NETCONF, Yang, and use of RESTful APIs. Background as an instructor, architect, and developer, James brings a passion for optimizing network automation, design changes, and most importantly, enforcing rigorous testing procedures. Mr. Henderson, please take the stage.
Hello, everyone. I gotta say I'm super happy to be speaking at NANOG. It's my fourth NANOG, and yeah. So I'm gonna get this started. Okay, from scripting to intent. So I put this talk together to show what it is about in terms of network automation that makes the difference between having something that's a script-oriented system and a real intent-driven orchestration. So I want to kind of take some of the marketing buzzwords out of this. I want to break it down to what are we actually trying to do in terms of orchestrating our network, and how can we go from having a system that is generally script-driven or generally manual to something that's intent, and why would we even want to do that? So to do this, I'm going to define what they are. We're going to use a real-world example involving VLANs to sort of describe the concepts. We will talk about what a service is and how that relates to intent, and talk about where workflows and templates fit in. We'll talk about source of truth, and whether or not there is one source of truth, or maybe there's sources of truths. And finally, we'll finish off with a service model for SD-WAN. Okay, so scripting versus intent. I think of scripting as being your most basic level of automation. And it's basically taking a manual process and then automating it. So it's like an automated manual. You have made the manual process faster, but you haven't really reduced the overall complexity of managing the system. So it doesn't matter how good the script is, you still have to provide all the same inputs that you would need to know if you were going to manually configure the system. If we're going to contrast with an intent-oriented system, then we're going to be using services to describe what our actual intended network state is. And we're going to be able to do that in a way that allows us to not think about some of the resources that we're trying to deploy. Now, at some level, it sort of seems like these might be the same. We're taking some variables, we're going to do some stuff, and then it returns, right? Either a script or intent-oriented. So what's the actual difference? Well, let's break it down and think about computer science for a minute. So in programming, we have imperative languages, and we have some declarative languages. An imperative language is something many of you may have used, where it basically, you go through and you tell it what steps to do. You tell it how to solve the problem. And you're going to modify data structures along the way. You may have dictionaries or lists, variables, change what the variables are, use for loops, all this stuff, right? Declarative language, on the other hand, will focus on the what. What is the problem that you're trying to solve? And defining the solution in terms of formal logic. Now, one of these is a lot easier to think about, but one of these is actually quite a bit more precise. Now, and there's a couple of declarative languages that many of you would have used. For example, SQL. If you're using SQL and you want to get a result, like you have, let's say, a few tables in your database, you want to join them according to some particular column, you just say you want to join them, and here's a key. And then you say, I only want to see results which are, above this value according to this cell, and I want to sum everything for this column. And I'd like to see the result. You don't have to tell the database how to do that. You just say what you want in a way that is unambiguous, and then the database will solve the problem and give you a result. Now, in a declarative system for our network, we kind of want to do the same thing. We want to define a language for our network that uses data, models, and functions in order to allow us to unambiguously control our network and have the system be responsible for actually making the change. Which means that all the parts of the control that we don't really care about from the use of a service, those can be handled by the system. We're not thinking about those resources. Let's consider a VLAN as a real-world application, something most of you are going to be familiar with. So a VLAN is a network segmentation technique. It allows us to have one physical network that's visible as multiple logical networks. And for our example, we'll say that we have a number of edge devices, and each edge device will have one client port per VLAN, and then it'll have a number of trunk ports. So in order to set up the VLAN, we need to configure the client port, we need to put the VLAN on that client port, we need to create the VLAN on the device, and we need to add that VLAN into the applicable trunk ports. And we shouldn't be probably just putting it on every trunk port, because this could be a very large network, and maybe the traffic doesn't have to go out every trunk port. So how do we do that? Well, let's take a look at our computer science theory again. In an imperative system, what do? Well, maybe we'll write some scripts to create our VLAN, and the scripts will go and they'll say, okay, for each of the edge devices, we add the VLAN to the client port, we add the VLAN to the applicable trunk ports. Which trunk ports do we want to add it to? Well, we're going to have to supply that as a parameter to the script. And then theoretically, we're going to want to document this, right? Because otherwise it's just, there's a VLAN on our system, but we don't really know what the, that VLAN is supposed to exist. It's just configuration on devices. So we should probably document what our intent was somewhere. That could be as simple as saving the script that we used in Git, or saving the arguments, or it could be an Excel spreadsheet, who knows. But somehow you should have that documented. Now, if we're going to have a declarative system to do this, you're going to have a state. So your state is going to be, what is the actual state of your network, which you're going to remember. And then you're going to update your intent, which will be to have a VLAN between these ports. We're not going to say anything about the trunk ports, for example, because they're not really, from the perspective of someone using the VLAN, they don't care about the trunk ports. They care about the client ports. They care about accessing and connecting to that VLAN. So no matter what, we're going to have some problems that we're going to have to think about. Doesn't matter what sort of system we use. We're going to have to think about, okay, after the VLAN is created, are we going to be doing assurance, for example, to ensure that this VLAN is working correctly? How do we make sure that we're not using the same ID twice? How do we make sure we get the ports correct? So these are all things that no matter what, we do have to think about them. So if we're using the script case, we're going to maybe have to check all the other VLANs that exist, look at the configurations on the device, make sure it's not, conflicting in some way. But in an intent-driven system, maybe we can do a little better. Okay, model it. So we can use a model in order to track this information. Not just the intent of the VLAN we want to create, but also all the information that's required to realize that intent. And when I say a model, I really just mean a structured way of storing information about your network. So, Yang data modeling is fantastic, but it's not the only way, right? To me, the most important thing is that you have structure rather than just having kind of commands that you're running. So let's take a look at the model. I've divided things into two models here, a service model and a resource model. Now, the service model is there to show you it's there to describe from an outside perspective what the VLAN is. So we can have it quite simple. We just say, okay, we have an ID, a name, and a description, as well as a list of devices and what their names and ports are. We don't need to put the IP address of the device. We don't need to say what type of device it is. All we have to do is say the stuff that will be kind of visible to someone who is using the VLAN. And the resource model can be responsible for storing all the other information that we need. And much of this information doesn't change VLAN to VLAN. For example, we have each of the devices that's involved, what their IP addresses are, what type of devices they are, all their client ports, all their trunk ports. And then we can have a network model that stores the existing VLAN, stores connections between the devices. What are the physical connections that exist between the devices? So if you were to try to figure out, okay, well, I have a VLAN I need to implement, here's the client ports. If I have a graph of every connection between all the devices, then I can determine mechanistically what are the trunk ports that I want to apply it to. And we get a second advantage because let's say we change the layout of our network. We decide we're adding more devices. So now there's more trunk ports. Or we update one of these VLANs, we can mechanistically, again, determine what are the changes that we need. We don't need to think about it. The VLAN definition never changed unless the intent of the VLAN has changed. Okay, so another good thing about this is that actually using the VLAN becomes pretty straightforward. Here we can see, just using curl on the command line, how we might create a new marketing VLAN. So far what we've talked about, a difference between imperative and declarative, given an example model. And now what I want to do is show a generic automation architecture. So this is going to be to kind of just show, regardless of any product, what are the things that you are going to need to implement some sort of intent-driven system. And I'll break down services, templates, workflows, the sources of truths, as well as, and then we'll get to our SD-WAN example. Okay, so generic service-oriented intent-driven automation. At the top here we have users, other services, and workflows. So these are who is actually, where the information is coming from. Where is our declaration of intent actually coming from? How are we using this system? And those are all going to be funneled into one API. Maybe the users are going to use a web UI. That web UI will then be powered by that API. This API is going to be mapped to our customer model, like we saw earlier. But in order to actually implement that, we're going to need to have some more information. So we need a database, which is going to store the state of our services, as well as the state of all the resource models that might be required to create the services. And we'll need to have a logic. And the logic will be responsible for making these database updates, as well as pushing the changes to the devices or potentially other APIs. Now you might notice that we have services on the top, and then we have APIs on the bottom, or you could have other services on the bottom. The idea here is that we've encapsulated some of the logic that you need to make a change. So instead of making one gigantic system to manage your whole network, you can have several small, well-defined systems, which have well-defined APIs, and solve a particular problem, and hide some resource management. When they provide a simple API, that enables them to, enables your entire orchestration to be simpler. And so then we have templates, workflows, and scripts. And those are basically going to be important for implementing our logic, right? We need to have some tools in our toolbox to accomplish that. And they're going to be useful. Okay, so what is a service and how does that relate to intent? I think one of the important things here, okay, so we have our API, we have our database, we talked about those, we have a hierarchical model. Having the ability not just to be passing key value store, and remembering that, if you have a hierarchical model, then you can do things like have a list of devices, right? Or lists of IP addresses, and you don't have to resort to having these kind of silly names like, device _1 _IP, device _2 _IP. And it becomes much easier to write code that's going to interact with the system. You can just have loops that will iterate over everything, for example. Easier to write templates as well. You need to have a service model that's defining your intended state, but not your process to get there. If you find your service model is saying a lot about how to implement the service, that's a suggestion that maybe you need to think a little more about the what of what you're trying to implement. A service should be a noun. You shouldn't have a service that has a verb in the name. So like a create VLAN service doesn't quite make sense. A service exists inside a life cycle. So for example, if you define a VLAN service, then you're going to have something called a service instance when you actually want to create a VLAN. That'll be a specific VLAN. So when you create that service instance, that's your create VLAN. It's not a create VLAN service, but it does create a VLAN if you create the instance. So there's a relation between the definition of the service you have in your system and the definition and the service which exists on the network. And services can be treated as resources themselves by their services. So this is the core of creating a simpler way of managing our network. Okay, so templates. Templates I see as fundamentally declarative. You write what you want to see in terms of config. So you're saying this is what the config should be, and you don't really tell it how to do the template. The template has a language, and the template will just be filled in according to all the inputs that you've given it, whatever variables. But you're going to need a bridge. It's not going to be enough just to have a template. You're going to need some bridge between that declarative template and the actual device. You need to apply the configuration that that template's created. And sometimes it's not that straightforward because there could be configuration already on the device. And it's possible that that config, if you had a template to remove a service, are you going to be bulldozing config that was used by some other service, for example? These are all things that you're going to have to think about. So it's a useful tool, but it's not going to be the whole toolkit. Here's an example of VLAN template. Part of the template anyway, it doesn't do the trunk port, but we create the VLAN, we add it to the interface, configure the interface. It's pretty straightforward to see how that works. Okay, so workflows. So I see workflows as also being imperative, but the real advantage with not also imperative, but they're as being imperative, but the real advantage of workflows is that, unlike a script, they allow you to really track where you are in terms of execution over time. So if you need to, you write your VLAN service, but then creating a VLAN, there's several steps you have to do. You need to do some pre-checks, you need to push it out to each of the devices, you need to make sure that works correctly, you have assurance stuff you want to do afterward. Your workflow can be something that allows you to visualize all of that and even put timers on things. Maybe you don't make changes during some hours. So you have to, you can set your intent on the workflow, it can wait, and then it can go. So it's very useful for tracking multi-stage changes, gluing resources together, and working to implement the service. Because we had in the thing, we put CRUD-V, create, read, update, delete, validate logic, right? So you have to implement it somehow. And workflows can really be a good way to do that. Here's an example of a workflow. You can visually look at it, you can tell what it's doing. You can see where you are in the workflow. You could have many instances of this workflow. For example, you could have, if you're doing an upgrade, you could have an upgrade workflow. Everyone, they're all set. And then when the maintenance window begins, they all start going. You can see where all of your upgrades are. Yes. There we go. I think I was blocking the IR. Okay, sources of truths. Okay, so we hear this term, single source of truth. And what I want to argue today is that there's multiple sources of truth in your network, and they're fundamental. They are each their own thing, and you could have one place where you're viewing them all, or one system that sort of collects and relates them, but they still exist in a fundamental way, and you should care about all of these. Because the ultimate is, do you care if your network is functioning correctly? Most of us are going to say yes. And so where does that begin? Okay, so let's talk about the physical state of our network. What is physically there? We have a rack, it has devices in it, and they're cabled up. And they have this type of cable. They're going, these types of transceivers. Then we have our intended physical state in the network. And then there's a mapping between those. So you may be planning an upgrade or planning a change, or you may need to validate that something is wired up correctly. If you don't have an intended physical state of your network that's somehow stored, then how do you know if it's actually correct? You don't really have a way of validating. It's just physically their devices, right? Then we have our behavior of our network. So the behavior of the network is what the network is actually doing. This is assurance tools, right? They can look at the behavior of the network, but it's how do they know whether or not the behavior is what you intended? You can say a link exists. Is the link operating at the capacity it should be, that the customer wants, or is it just operating at a capacity? And so, okay, well, to solve that question, maybe you could look at the configuration. So you look at the device configuration. What configuration is on the device? Now you could say that, okay, the behavior's right, the configuration's right, behavior matches the configuration, but did you intend to configure it that way? So then you have your intended configuration of your network. So if you just run a script, it will configure the network in some way, but did it configure it in the way that you intended it to? Then we have our intended network services. So if you just intend to create some configuration, but that configuration is not actually creating a network service that's cohesive, what value does that have? And finally, we have the history of the mapping between all of these. So if we are changing, for example, the way that our services are working, and we want to track, we want to know, for example, we have an assurance that we're doing. We want to have some idea, as we change the service, which devices have the new service on them, right? You could have thousands of instances of the service. If you just change the logic behind the service, this CRUD-V logic, then do you actually know which services have the new logic and which ones have the old? What's your plan to move between them? Are you just writing that down? Ideally in a system, this is also something that you're going to track. And then you have the ability to look at historically and say, well, the configuration we had, we're on this standard, and this is what the performance was, and then we changed standards, and this is what the performance was. And you could see that over time. And have an ability to go back. What if you start changing things and then you realize the new standard is not working out for some reason? You want to go back. If you lose that old logic, you're going to have a challenge. So that's where versioning comes in, right? Okay. So the next example I want to give is SD-WAN. SD-WAN is going to allow multiple customer sites to be connected across disparate links using a single overlay network. So the network itself is, it could be provided, it could be MPLS, could be WAN links, could be anything, right? What I want to focus on is for customers, if you have QoS policies, allowing customers to share their QoS policies, and just showing what it would look like to create a model for SD-WAN, a simplified model that doesn't take into account who the actual provider is, but rather is trying to define a generic concept of SD-WAN. So here's our architecture. We'll have a customer portal. That's going to allow the customer to make their own updates. We have customer service. And the customer service is going to be our customer-facing service. That's the one that we saw from before. And then resource service, any resources that we need to allocate to properly implement things. We're going to look at the customer service. So first of all, let's take a look at traffic classification and QoS. So we have this idea of traffic classification apart from any particular customer, which we can configure. This is like the model where we said we had a model of our physical network, for example. Here we have a model of different traffic classification policies, different QoS policies and profiles. So you can build up the QoS policies for multiple traffic classification policies and create profiles, which are combinations of those QoS policies. Now this is actually simplified a little bit. You could certainly add a lot more detail and lots more parameters if you wanted, but I just want to show the ability to create standardized models that then could be referenced by customers who don't want to control every single detail of their QoS. For example, here we have this healthcare profile. We've defined a number of policies which are part of it. And then each one of those policies is going to have a QoS class and some way of classifying traffic into the policy. And then each of the traffic classifications would have maybe a list of different rules which we're applying for that. And then here's our SD-WAN servers. So our SD-WAN service can now reference that QoS policy that we've defined that could be applicable to multiple customers or could be applicable to certain applications. And then we also have the ability to do an override. So we could say, well, we have the policy, it has an ID, you have a traffic, and then we have a list of traffic classification rules. And so we could say that we have some critical apps policy, for example. Then below we have our site list. Each site would exist there. We could also have added like a QoS policy per site if we wanted. And we list our links. So this information is really what you need to implement like an SD-WAN service, regardless of the actual provider. And it's a lot simpler than the configuration. So of like the provider SD-WAN service configuration. So this would allow us from here, we could develop our web UI, for example. Okay, so if we put a QoS policy profile on a customer here, and then we could have our kind of overrides for that particular customer. All right, so now what? Well, we could provide a NetConf or GNMI interface based on that model. We have the advantage here is that because we have the intent of that for that customer, we know what assurance we need to actually run for that customer. We could create standardized graphs. We could have telemetry support and have a Grafana instance for that customer that they can view on their portal and view all their statistics just for them. without having to rely or worry about any specific provider information. And then, of course, you have your ability to have the web UI, add the customers, and then you can integrate billing. All right, so what? Why do we even want to do this? Well, now when our customer wants to change, they can change their connections in minutes, not days waiting for a change request. The customer will easily see what services they have. The provider will know what the intent of the customers is to connect that intent to reality using telemetry and plan for capacity improvements, and we have reduced our risk for human error. From this intent model, we can add whatever checks we want, whatever validations we need. Okay, finally, I want to say that scripting and intent are not in conflict. They are, but they're not the same. We should be aware of when we're using an imperative system to say how to make a change versus a declarative system that says what the changes that we want to do. And resource hiding will be the key to scalability in management. If we can't hide resources, then we have essentially an unlimited amount of complexity that we have to manage over time. I'm going to put a couple questions up here just to sort of think about how intent-driven networking could affect your networks, and open the floor for any questions.
Hi, question. Ruben, I work for T-Mobile. Question is about the diagram that you had, right? You showed two APIs. Is one of them abstracted?
Two APIs?
Yeah, like there was an API in the middle.
NETCONF,
and the
DNMI?
Yeah, I don't remember what exactly they were called. If you go back to that slide.
This one?
No, the flow chart that you had, right? You had one with the flow chart?
Oh, the flow chart. Yeah, yeah. This one?
No, before this.
Forward?
The one with the CRUD.
Oh, that one. Yeah, yeah. This one.
Yeah, this one. You have two APIs there. Is one of them an abstracted API?
So the idea here is that the top API, that's the API. I should probably put a box around a database API and CRUD-V. And the idea is that API is the gateway to the service that you're providing. The lower API is an API that you, in order to provide that service, may be using. So that could be another, basically, iteration of this same sort of core design. The idea being that each one of these will collapse some resource management so that you have a simpler way to manage your network.
Okay, so like one would be like a vendor specific or a device or a type of function specific. The other would be abstracted all the way up.
Yeah, it's basically an API or a service calling a service.
Okay.
That's what we're showing.
Okay. I have another question as well. The way I'm not an SD-WAN guy, so I don't understand that part. But you have like customers making their own changes, right?
Yes.
So is it built to be like a multi-tenant solution in a way?
Yeah, like in this design, it's just from the customer's perspective, right? They have a box, it does SD-WAN, right? They want to be able to have their system working and have a way to modify that and see their own view of it. They don't really care about other customers, even though that's a managed service that's being offered. So the web UI is designed to be focused for them, so they have an easy way to either automate or just manually click in and make changes to their SD-WAN environment.
Okay, and that would hit the first API there? That's
Yeah, so that would be like our users there, right? And then you'd have like a UI, it's not written in there, but some sort of user interface that they could use. But that would always be backed by an API. So then that API could be something, they could write their own services if they wanted and say, if I want changes to SD-WAN as part of this service rolling out internally, then I can hit that API and I know that will update my managed SD-WAN service.
Okay. Thank you.
You're welcome.
Any other questions?
All right.
Great thing about being able to read along with the slides.
Yes.
Yeah, you have a question? Come on up. Go to the mic, please. Introduce yourself with name and your company, please.
Hi, I'm Jared Cordova. I work with Nokia.
Hi.
So you had some questions that were on the slides at the end.
I did.
Yeah, one of them you asked, what are some complications or difficulties that you see with this type of model architecture? What are some that you see that could be problems?
Okay, so I've seen a number of challenges. One big one is, especially in larger organizations, if you have different silos in the organization, they're often fairly unaware of what each part of the organization is doing in terms of an automation strategy. And if you want to make these compatible, right, we have all the APIs connecting and everything, you need to have, in my opinion, a single sort of automation program across your organization to determine how automation is actually going to function in your organization, have a plan for that. Because you can create models, but if those models aren't complete, because they'll always end up needing resources in other parts of the network eventually. And if you don't have any way to automate that connection or any standardized plan for that, then you're going to have pain, because you could perfectly automate your silo, but if all the operations going to another silo end up being manual, then you'll have challenges basically, or you'll end up re-implementing stuff that was already implemented somewhere else.
Okay, yeah. Thank you, appreciate it.
Oh, no problem.
Hey, James, thank you for taking the last second.